you by thesis123.com. I learn and teach online.
Here's the next question, number 17. A 3-bus power system network consists of 3 transmission lines. The bus admittance matrix of the uncompensated system is this matrix right here. If the shunt capacitance of all transmission lines is 50% compensated, the imaginary part of third row, third column, that would be the final element of the bus admittance matrix after compensation is, so we have our 4 options, minus J7, minus 8.5, minus 7.5 and minus J9. Okay, so the first thing we have to do is let's write down what an admittance bus looks like with its elements. Note that we will have to keep the diagonal elements as positive while the rest of it would be negative. Okay, so I'm going to write that down now. Y bus would be equal to Y11 minus Y12 minus Y13 minus Y21 minus Y22, plus Y22 minus Y23 minus Y31 minus Y32 and Y33. So note here that the diagonal elements are positive. Okay, so the next step is to find out the admittance between the bus and ground. Now between the bus and ground we note those admittances as Y10, Y20 and Y30. Because here the question says that we have 3 transmission lines, so we will have to find out the admittance of each line between the bus and the ground. Okay, so I'll write that down. We need to find the admittance between bus and ground. So these are the 3 components, Y10, Y20 and Y30, indicating the admittance between the bus and ground for each of the 3 lines. Okay, so now how do we get these 3? Y10 is equal to J1. How, you ask? Well, the key is to add all the elements in that particular row. Now look at the matrix given to us. The admittance matrix of the system is this right here. Now in order to find out Y10, we will have to add the elements of the first row. Add the elements of the first row and see what you get. Minus 6 plus 3 plus 4. So you get 1J. Similarly, add the elements of the second row to get the value of Y20. So that's 3 minus 7 plus 5 and that will give you J1. Similarly, Y30 you will obtain by adding the elements of the third row. So that's 4 plus 5 minus 8. That gives us again J1. I hope that is clear. So far we have found out the admittance between the bus and the ground. So the first step is done. Now the question says that all shunt capacitance are 50% compensated here. Now because they are 50% compensated, that means that Y10, the values of Y10, Y20 and Y30 becomes half of it. They are 50% compensated. In other words, it's 50% reduced. So let me write that down here. All shunt capacitances are 50% compensated, meaning 50% reduced. So y10 would now become j1 by 2. y20 would become j1 by 2 and y30 would become j1 by 2, reducing it by 50%. So each one of these values becomes j.5. 1 by 2 is 0.5. Now for the final step. The question says that we need to find out the imaginary part of the third row, third column. Third row, third column is y33. Okay? So, to find out y33, and this is the new component. Okay? So, y33, we will obtain y33 by adding the value y30 plus y31 from the matrix that has been given to us in the question plus y32. So from the matrix given here, y31 and y32 are added to y30 because we are finding out the new element here of y33. This is y33 old. We are finding out what is y33 new, the new element or the new value. So we add y30 of what we have just found to the two values here, j4 and j5. So let's put that down here, j.5. Okay, so here you will have to be very careful because now if you notice the y bus that we have written here down below, the diagonal elements are positive while all the other rest of the elements are negative, which means we will have to consider j4 and j5 as negative. So that's a negative j4, negative j5. It depends on the standard y bus that we have drawn down there. Now if we solve this, we get minus j8.5. So this is the imaginary part of the third row and third column. So minus j8.5 matches option B. So this is the entire solution and I hope it helps.
Thank you for watching this video. For future videos, please click here to subscribe YouTube channel. Visit our site thesis123.com for free student project or research ideas and online training. Follow us Facebook, Twitter, Google+ and Pinterest.